Supernormal growth dividend. Let's look at what this is and how we would solve a problem like this one. And this is what I call a 10 out of 10 difficulty level, because even though it looks very simple at a first glance, it's kind of tricky how you solve it. Let's say we have the following. We have the discount rate, let's make it a 25% annual rate. And then what do we know about the stock dividends in the future? Because this is something we need to assume, as if we know what the future dividends would be, even though in real life this is never the case. Year 0, year 1, year 2, year 3, year 4, year 5. Let's mark those. Let's say we know that the company is planning to pay a $4 dividend next year. So this will be the first dividend you will receive if you buy a share of stock today. And how much would you pay for this share? This is what we need to find. Find stock price if future dividends are so and so many dollars. And this is what we know about the dividends in the future. They will be growing first at one rate and then at another rate. Okay, so let's say for the first 3 years, the dividends will be growing at a very high 50% rate, 50% growth. And then over the remaining years, so in perpetuity, they will be growing at a different rate. Let's make it a 20% growth rate, right? So what kind of company would that be? Maybe it's a startup, a new company which came up with this great idea. Customers love this product, they buy a lot of it, and the company would be making huge profits, growing by 50% every year, which would allow the company to pay a 50% increase in dividend over the first years. And maybe after year 3, other companies will jump in and start competing with our startup, and that would take some profits away from our startup. And as a result of that, the growth of our startup would slow down, and so will the dividends. Okay, this is all we know. The interest rate is 25%. That's our discount rate. And the first dividend that you as a stock share buyer would be receiving is $4 next time the dividends are paid, which is in 1 year in our problem. And the two growth rates, 50% per year over the first 3 years and 20% after that in perpetuity. The easiest way to solve this problem is to calculate a few more dividends after the one that's given. So if in year 1 it's $4 and then it will be grown by 50%, what's 50% of $4? It's $2. 4 plus 2 equals 6, right? Then so it's the same thing as 4 multiplied by 1 plus 50%. Now, year 3 dividend. What's 50% of $6? It's $3, half, right? 6 plus 3 equals 9. $9, which we found by taking 6 and multiplying by 1 plus 0.5 again. Is this how we would keep calculating the future dividends? No, we cannot use the 50% dividend growth rate anymore after year 3, because after year 3 it changes to only 20%. Okay, what's dividend in year 4? We take $9, and just like we did in the last 2 years, we multiplied by 1 plus 20% growth, which gives us $10.80, and so on in perpetuity, right? And actually this is what we call a growing perpetuity, because a regular perpetuity would mean $10.80 every year after year 3 forever, but that's not what's happening. the dividends will be growing by 20% in perpetuity. Okay, how would we approach this problem? Well, what we have starting year 4, right, is a growing perpetuity, right? Year 4 is the first dividend, the year of the first dividend that will be then growing by 20% forever. Okay, if we use the present value of a growing perpetuity formula, growing perpetuity, then it tells us that we need to take $10.80 and divide by the interest rate, which is 25%, that's given, minus the growth rate of dividends, which is 20%, right? So what we have is $10.80 divided by 5%, and that gives us $216. So what is $216? It's we discounted all this entire growing perpetuity, right? Year 4 and thereafter, and we found the present value of it in year 3. This is what's built into this present value of a growing perpetuity formula. It gives us the value, kind of the sum of all future discounted dividends, not in year 4 where we have the first one, but one before that. So we need to go back 1 year, and so this is for year 3. And what we have now is essentially the following, as if we have the following. This is what we've just done. We took our timeline and changed, essentially we changed the numbers on it a little bit. So now instead of having 4, 6, 9, 10, 80 and so on forever, we have 4 in year 1, 6 in year 2, and in year 3 we have 9 plus 216 that we have just found for the growing perpetuity. If you combine the two, which is just simplifying what we see on the timeline, we are looking at a total of 225 in year 3, right? And so we have nothing after that, nothing else. 4, 6, and 25 in years 1, 2, and 3 respectively, and nothing else on the entire timeline. And now it's very simple to find the stock price today, right? Now what we want to find is what will the price be today. And the price of any share of stock of any company is nothing but the present value of all future dividends, right? Think about how much you would be willing to pay for a share. No more than how much you get back, right? But we wouldn't be just adding the dividends up, we would be adding their discounted values, their present values, how much each of them is worth to us now. The best way to do it in the financial calculator, let's turn it on, is to use the so-called cash flow keys. You press the cash flow button, second row, second button. Cash flow 0, we don't have any dividend right away, so we keep it at $0, press enter, and then the down arrow key. Cash flow 01, that's the first one in the future, it's $4. We press 4, enter, and the down arrow key. Now, frequency of it, how many times do we have $4 consecutively? Only once, so we keep it at its default value of 1. We press the down arrow key for the second time. Cash flow number 2 in the future, that's $6. We press 6, enter, down, and down again. Cash flow 03 in the future, that's a total of $225. I press 225, enter, down, down. That's it. There is no more cash flow 4. There is no more cash flow 5 or 6. We are done. Because $216 replaces all the dividends beginning year 4, continuing in perpetuity. 216 replaces all of them with this number. Okay? Then to find their combined present value, we press the NPV, enter the discount rate which is given, 25%, 25, enter, down, and the last button I press is compute. $122.24. Okay, so $122.24. This is my answer.